Fuel system design usually involves the complexity of codes and regulations, as well as a need for coordination amongst other building systems. So at the start, it's best not to lose the forest for the trees. We wanted to give you an overview first.
You need to address a variety of issues to set up the project for design success. These issues are user needs, codes and regulations, design integration, and system detailing. User needs, such as the building loads and the expected runtime during emergencies, will determine the size of the fuel system. The site location will determine the fuel storage location. For example, a high-rise building in a downtown urban area will require fuel storage inside the building. An understanding of the user organization and technology will indicate the degree to which the fuel system should be monitored and integrated into other building systems. In other words, you must determine if common alarms should be indicated for the operating staff, or if a full reading of system characteristics should be integrated into a facility-wide building management system. After the user needs are determined, you need to understand relevant codes and regulations. You will most likely need to investigate the local requirements for fuel system design. NFPA 30 is the starting point for most U.S. codes and regulations. Most state and local requirements are variations of this national code. Whether the tank is underground, above ground, or inside a building, you should review the relevant parts of the code. State codes are usually more detailed for underground tanks. Local codes will be more detailed for tanks above ground and in buildings. When the basic requirements and rules of play have been established, think about your team. You will need architectural, structural, civil, electrical, and control specialists. Get them up to speed on your basic needs and limitations to prep them for more detailed integration issues to come. Finally, think about the details or deliverables needed to design the fuel system to allow for successful construction and operation. Design details for fuel systems should include equipment lists and specifications, installation details, flow diagrams, and a sequence of operations. Facilities with emergency power systems are critical and complex. A high level of coordination is required amongst the design team. You will need to deal with several integration issues. The architectural issues you need to worry about are building exterior aesthetics, access and egress, and room occupancy and fire rating. Structural issues include tank foundation calculations, seismic calculations for equipment supports, wall penetration for piping and conduits. Civil geotechnical issues are underground utility routing and tank area, excavation characteristics for underground tanks, and roadway layout and access for fuel delivery and emergency vehicles. Electrical issues are power requirements for fuel system equipment, coordination of generator accessories such as day tanks and filters, and the coordination of fuel system control points needed for generators and switchgear. Building management system coordination is a determination of the points to be monitored and the communication protocols. Fire alarm and security system issues are a coordination of any required fuel system control points for these systems.